The lifeblood of modern society, our electrical grids are under a growing threat. This isn't a hypothetical scenario from a dystopian novel or a Hollywood blockbuster. It's a sobering reality happening right here, right now. Our electrical grids across the United States have seen an alarming surge in attacks. In the span of just a year, from 2021 to 2022, these attacks increased by a staggering 72%. That's not a figure to be taken lightly, it's a wake-up call. These attacks have served to expose the vulnerability of our critical infrastructure. They've shone a harsh spotlight on the fact that many of our substations are woefully underprepared for such threats. Adequate security measures are sadly more the exception than the rule. These substations, the beating heart of our electrical infrastructure, have become easy targets for vandalism and sabotage. And the culprits? Right-wing extremists aiming to sow chaos and accelerate societal breakdown. Their motives may vary, but their actions speak louder than words. Our law enforcement agencies are doing their best, but they're struggling to apprehend these perpetrators. The majority of these attacks remain unsolved, a chilling testament to the cunning and audacity of these criminals. The Department of Homeland Security hasn't been idle either. They've issued warnings about threats to our critical infrastructure. These threats aren't just from large, organized groups, but also from individuals and small groups motivated by a myriad of ideologies. With many attacks still unsolved, it's clear that our electrical infrastructure is at risk, but recognizing the problem is the first step towards finding a solution. Stay tuned as we delve into this issue further and explore potential solutions to safeguard our power grids. While our grids face threats, there's also a shift in the energy sector. A new player is emerging on the global stage, one that could dramatically alter the way we generate, distribute, and consume energy. That player is hydrogen. In the fight against climate change, hydrogen is stepping up to the plate. It's clean, abundant, and remarkably versatile. But there's a catch. Hydrogen is also highly volatile, which means that handling it safely requires a keen understanding of its behavior. That's where real-time monitoring comes in. Advancements in technology have led to the development of miniaturized sensors capable of monitoring hydrogen levels in real time, providing a crucial safety net in various industries. From electrolyzers, which split water into hydrogen and oxygen, to energy grids and pipelines that transport this element, to refineries where it's used to produce a variety of products, and even battery backups that rely on hydrogen cells. These sensors are there, keeping a vigilant eye on hydrogen levels. These sensors don't just enhance safety, they also boost efficiency and aid in operational decision-making. By allowing us to closely monitor hydrogen levels, we can optimize its use, prevent wastage, and mitigate potential risks. But the real power of these sensors lies in their potential to expand the safe utilization of hydrogen. As we continue to explore new ways to harness this element, these sensors will play an increasingly pivotal role. They will help us navigate the volatile nature of hydrogen, giving us the confidence to push the boundaries of what's possible with this promising energy source. This real-time monitoring technology is essential for expanding the safe utilization of hydrogen and reducing risks associated with its volatile nature. Amidst threats and shifts, a new technology emerges. Picture the transformers you're familiar with, those large, cylindrical devices often seen hanging from power poles. Now imagine them in a completely new light. Enter the world of solid-state transformers, or SSTs. They're a cutting-edge type of AC to AC converter used in electric power distribution, and they're poised to revolutionize the way we think about energy. These SSTs operate at high frequencies, making them more efficient and compact than traditional transformers. Just think about it. Instead of those bulky cylinders, we could have small, sleek devices performing the same job, but better. More than just being smaller and more efficient, SSTs also come equipped with active voltage and current regulation capabilities, adding an extra layer of control to the power distribution process. But the innovation doesn't stop there. Some models of these transformers can convert single-phase power to three-phase power and vice versa. This flexibility allows for a more adaptable power grid, capable of handling a variety of power sources and demands. And there are even models that can handle DC power, pushing the envelope of the efficiency even further. Now you might be wondering, if these solid-state transformers are so great, why aren't we using them everywhere already? Well, the simple answer is that they're still in the emerging stage. Like any new technology, SSTs are complex electronic circuits that need robust design, especially to withstand surges. Engineers and scientists are working hard to refine this technology, and there's much excitement about the potential it holds. Even though solid-state transformers are complex electronic circuits that require robust design to withstand surges, they represent a promising solution to our power distribution needs. As we move forward, navigating the threats and shifts in our world, the emergence of solid-state transformers offers a beacon of hope for more efficient, adaptable, and resilient power distribution systems. As we look to the future, it's clear that changes are on the horizon. Our electrical infrastructure faces grave threats, with a recent surge in attacks exposing its vulnerabilities. From Moore County, North Carolina, to the furthest corners of the United States, the need for robust security measures has never been more palpable. We can't afford to continue overlooking this glaring issue. But in the face of these challenges, innovation emerges as our guiding beacon. The energy sector is on the cusp of a revolution, with hydrogen making waves as a key player. Its potential is vast, from electrolyzers to energy grids and pipelines. Yet we must tread carefully, ensuring real-time monitoring for safety and efficiency. Then there's the promise of solid-state transformers, an advanced AC to AC converter that could redefine power distribution. Compact, efficient, and versatile, these transformers could be game changers in our electrical infrastructure. As we navigate through these challenges and embrace new technologies, our electrical infrastructure stands on the brink of transformation.